Okay, I'm going to do the odd numbered problems, and then for the even numbered problems, you're going to see some hints on the screen. So when it's time to do an even numbered problem, you can use the odds as models or the hints that you see on the screen for the even ones. So we'll start with number 1. When you're talking about on the grid problems with graph paper, we're going to use the fancy notation that we learned originally. When we get off the grid, we'll use the narrative, the words that we talked about yesterday. So number 1 is on the grid, and it's a multi-step problem, and you can see right here I have evidence of there being 2 steps. So we're going to take triangle ABC, and we are going to reflect it over the y-axis, and then from there over 0 and down 8. That's what it looks like in notation form when you're using an on-the-grid picture and there's more than one step. Now it's not on your paper, but number 2, we're lining up ABCD with UVWT. This is only a one step, so try to take it from there. Make sure the letters correspond. Okay, number 3. We are taking triangle BCD and mapping it onto MNP. The first step I'm going to do is reflect it over the x-axis. So I'm going to reflect it over the x-axis, step 1. And then step 2 will be to translate it over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2. Then I translated it over 9 and up 2. In number 4, again, not on your paper, but we are lining up ABC with DFE. They're not in alphabetical order. ABC with DFE. And here's a little hint for you. You might want to get out your patty paper and focus on the origin there. Okay, number 5 is an odd problem, odd numbered problem. We were asked to take LMN and map it onto QRS. So the first thing I did, I already have it drawn here, is I translated it first. And I translated it by choice so it lined up right on point Q there, so then I could easily reflect it over the y-axis as a second step. So what was the translation? It looks like it went to the left 3 and up 12. So my first step was translating -3, +12. Then, once I have it up here, I simply then reflect it over the y-axis. Number 6 wants us to take pentagon JKLMN and map it onto ABCDE. So there's a hint, a couple of hints here. It's going to be 2 steps. I'm showing you this, and I'm showing you this. So you might want to get out your patty paper, try to end up on the pink, and then take it that second step. Number 7 is an odd numbered problem. So it's screaming out rotation the way that it's sitting. So I attempted to test the origin, put my patty paper over, traced everything, including the letters RST. And when I rotate it about the origin, I find that it does in fact map perfectly on to FGH. So what I did there was one step. I rotated about the origin clock or counterclockwise, which is positive 90 degrees of triangle RST. At first this looks like it would be an easy reflection. As you look closer though, the x-axis is not your answer. It says reflect over a horizontal line, but where does the horizontal line have to go? Is it at y equals 8, y equals 6, y equals 0, y equals -3? You tell me where this should go. Where is the line of reflection? Okay, this concave pentagon looks like it's been rotated somehow, but certainly not by the origin, because everything seems to be shifted to the right a little bit. So how did I find what that center of rotation appeared to be? If this were off the grid, you could take two corresponding points, for instance J and D, and give me your perpendicular bisector. Then you could take another pair of corresponding points, which might be E and N, and give me those in the middle. And what you'll end up with, and I'll help you out here, is a center of rotation at 3.5. And another way to find that on the grid would be, how do you get from J to D? You go up 4 and over 3. Well, halfway between that trip of 4 and 3 would be the center of rotation. So instead of up 4 over 3, go up 2 and over 1.5. And that is your center of rotation right there. And you'll see that if I rotate about that strange point, 3.5, 0, I end up right on the shape. So what I did was I rotated about the point 3.5, 0, 180 degrees, and I did that to DEFGH. And your hint on number 10 is to start with ABC, which is right in here. And look what happened there to get to the pink one. So I took the red striped one and it became the pink one. That first step goes right here. And then what do I need to do to get the pink one onto the final one? Okay, number 11 is very similar to what we did in class yesterday, and I have a lot of the blanks already written for you to fill in the appropriate right terminology. We are now off the grid, no more graph paper. So we are going to, in this case, reflect triangle ABC over segment CD such that A maps on to B. Eventually, A has to map on to B. On number 12, we're taking triangle GEH and trying to map it onto DEF. So I'm going to have to notice that H has to end up on F. So it can't be a reflection, it has to be a rotation in this case. So I'm going to rotate triangle GEH about point E such that H maps on to F. Number 13, I'm going to take triangle QRP and I'm going to rotate it about the fixed point P such that R maps onto M. You could also say Q maps onto N. Either one will work. And here's your hint for number 14 right here. Follow that wording and fill in the blanks. 15 wants me to take this triangle at the bottom here and map it onto CED up here at the top. So I'm going to notice that it can't be reflected because B has to end up on D. So that's going to be another rotation. So I'm going to rotate triangle AE, that should be a B, AEB, about point E such that B maps on to D. Number 16, that looks intimidating with all those words and blanks there. And it's only because there's two steps. And the hint that isn't on your paper is that gray dotted outline. It just needs to be moved over to here before you reflect it down there. So a translation will move it. So J has to go on to F. And once that happens, then I can reflect it downward. So there is your hint on the right there. First, you're going to translate JKL along vector. You have three choices here, vector and three different choices you can pick, such that one point maps onto a new point. Then we're going to reflect the new J prime, K prime, L prime over this right here, such that an older point maps onto a newer point. And here's where we practice our fancy lingo here. Explain why the last problem that we just talked about. Explain why the original is congruent to the image. Because only two rigid motions were used, and they preserve what and what measure. These are the two key words. I don't want you to say size and shape. I want you to say what and what. And number 17, the last one. This looks like it could be a translation, except for the fact that A ends up mapping onto E, which is way over there. And we know that because of the original statement right there. So this looks like it's going to be a reflection informally over a line somewhat like that. So we are going to reflect triangle ABC over the perpendicular what of, you can either say BD, or you could say AE, or you could say CF, because they all have the same perpendicular bisector right here. So you reflect over that perpendicular bisector such that you could say C maps onto F. Whatever didn't get finished in class will just be finished tonight for homework.